All right, welcome. This is the first lecture in this series of lectures that I'll be recording over the coming weeks and months. And I'm excited because it's a series of lectures on this book, my new book with Joe Garbini and Cameron Devine. So I'm Dr. Rico Piccone. I'm a professor at St. Martin's University, and this series of lectures is on real-time computing for mechanical engineers. So we're going to start off with an introduction to Chapter 0, which is the first chapter in the book, and we're going to introduce each section as a separate lecture video. So I hope you come along for the ride. I hope you get the book. I hope you go to the companion website, which can be found here, rtcbook.org. And this is the link to the MIT Press website for the book, where you can get a copy of the book. You can buy it. And for instructors, there are also a bunch of resources for that. So this is the book. This is the cool cover. This is a Kandinsky painting. And yeah, I'm really excited to get into these lectures with you guys. Leave questions in the comments if you have them. And yeah, there's hardware that goes along with this. You might have seen this is a lab-based approach. So we're going to be getting into working on actual hardware as well as part of this series. So pretty excited about it. I hope you come along. So the main objective of this book and course is to introduce real-time computing fundamentals by implementing digital control for a mechatronic system. So we're going to get into which specific mechatronic system in the next section, but it is a specific set of hardware, and we're going to be writing software to go along with it. So yeah, introducing real-time computing, digital control, and a lot of mechatronics concepts as well. Okay, a practical learning platform is provided through the control of an inertially loaded motor. So the hardware is pretty extensively described on the website and in the book, and we'll go through it also in the coming lectures. But it includes a motor, a small DC motor that we're going to learn how to control, position control and velocity control as well. Those are some of the later lab exercises, later chapters, and early on we're going to learn how to program a user interface as we get familiar with programming in the C programming language, as we'll see. This motor system offers dynamic complexity to explore various digital control issues. So there are many topics that we're going to need to get into, and this platform allows us to get into a lot of those topics. So that's why we chose it. And finally, topics include creating a digital user interface and implementing control mechanisms. So this chapter serves as an orientation to the methods, concepts, hardware, and software discussed throughout the book. It introduces the structure of a specific real-time system and the basic process of programming it. So we're going to introduce the integrated development environment in which we're going to program this piece of hardware. The chapter also covers some of the basics of the C programming language, because I do not assume that anyone who's taking this course or is starting to read this book has programmed in the C programming language before. So as long as you have some programming familiarity, whether that's in Python or MATLAB or really any language, that should be sufficient background for this. So the chapter also, it begins with an overview of the hardware and software systems used in real-time computing. So kind of generally and then more specifically, programming the target computer requires a software development environment. And we're going to go through how to set up our own development environment, our own development system. Learning is hands-on, combining hardware and software exploration with conceptual learning. So it's going to be a lot of conceptual topics. We're going to introduce each chapter sort of just in time for the labs. Sometimes we're going to go into some topics that we won't get to instantiate in the labs, but other times we will. In most cases, the topics that we'll introduce in the chapter will be exercised somehow in the lab exercise at the end of the chapter. They build on each other throughout the semester, so we have to go through it sequentially. Okay, finally, readers are encouraged to assemble and configure the hardware and software while progressing through the chapter. So for each chapter, we're going to be going through topics that are theory-based topics, and then we're going to be applying them in the lab exercise. So follow along. If you don't yet have the hardware, that's okay. The hardware can be emulated for many of the labs, if not all of the labs. So you can do emulation, but we do really encourage you to get the hardware, if at all possible, because it is so valuable to have that hardware experience. It really helps make it real. So each chapter, including this one, concludes with the lab exercise for practical application. Lab exercise 0 focuses on writing and debugging programs to control a real-time target system. So we're going to learn how to write a basic program and how to implement it on our target system. Each lecture will cover a section in the chapter, concluding with a lecture introducing the lab exercise. So we'll get on to the first section in chapter 0 next. All right, we'll see you then.